Alright, hello, and welcome to my review of Big Data for the AWS Specialty Certification. So I'm reviewing some of the notes I've taken for their white papers and from some of their documents. And this is mainly a review of things that I thought were kind of hard to remember or I didn't remember especially very well. So these are some of the notes. I've written them down previously, and then I'm going to go through some of them now. So big data does have a lot of storage and analysis tools. And what Amazon Mechanical Turk can do, it can crowdsource your marketplace so you can have real people do solve real problems. So you can get these real people to solve these jobs for you. You can have these people validate your databases and have them do research for you if you want them to. Of course, you have to pay them. You can have them participate in your surveys. You can have them moderate your content and check if the data is being duplicated or not. That's very useful. If you have production databases and you want to make sure that there's not a bunch of people that are duplicated, that can cause a lot of errors. You can also build machine learning workflows. So with that, you might need a bunch of data, so you can have these people get the data for you for all your machine learning purposes. All right, let's get down to data analytics. So what data analytics does, Kinesis data analytics, is you can analyze the data on your Kinesis streams. So you can process and analyze real-time streaming data. So you don't have to learn a new language for this. You can use SQL, structured query language, and it'll all be done and streamed in real time. So some of the use cases for Kinesis data streams is you can use real-time data analytics. You can use log and data feeds, intake, and processing. You can use real-time metrics and reporting. You can use each shard, which will have 1 megabyte per second at 1,000 writes per second per each shard. So if you need more than that, you're going to need more shards, of course. And you'll get 2 megabytes per second for reads. So the replicas for each of these, some companies have requirements for replicas. These are replicated across 3 availability zones. So cursor can be used to track what has been read from these Kinesis streams. So if you need to check if something has been read or not, you can use cursor. So how you get this data into the stream? Well, you can use KPL, which is the Kinesis Producer library. You can use the Amazon Kinesis agent on an EC2. You can use Kinesis Put API as well if you want to use that in one of your own programs. So some of the anti-patterns for Kinesis is if you have small data, so this means less than 200 kilobytes or around there, it's not very efficient because Kinesis was built for large, big data. That's what we're trying to understand here, big data. So it also has an anti-pattern of long-term data storage. So if you cannot store something forever, so if you want to do that, you'll need to use S3, Glacier, Redshift, or DynamoDB. Okay, on to Presto. So what is Presto? So it's a SQL engine that you can use to basically query things. So for interactive analytic queries over large data sets from multiple sources. So this is run on EMR 5.0 and later. So it has fast queries with data of any size. So, well, they say any size, but there's of course a limit eventually. So it also will support non-relational and relational sources. So like NoSQL and SQL. That's pretty useful. You can query data where it is stored. So you don't have to store it in new places. So moving on to Hue. What is Hue? Hue is the Hadoop user experience. So it is web-based. It's a graphical user interface. It makes it easy for you to see things, see what the data is going on the screen. So you can use it with EMR and Hadoop and acts as a front end for things running on your cluster. moving on to Lambda with big data. So if Lambda fails and it's invoked asynchronously, it's retried 3 times, and if it's hasn't worked for 3 times, it's going to be rejected. So that's opposed to invoked synchronously. I think my roommates are lighting my house on fire. I'll be right back. Actually, no, I'm not going to be right back. We're just going to go through it. Redshift. So Redshift, each cluster has a leader node and 1 or more compute nodes. So leader nodes receive queries and develop query execution plans. They can aggregate the intermediate results of those queries. So what does that mean? So that leader node is going to get a query from someone, and then it's going to develop a plan on how that query can be fulfilled. Oh my gosh. I think I'm going to die here from the fire and the flames in my house. So compute nodes follow these queries. My Alexa just woke up when I said compute because its wake word is computer. So compute nodes will execute these queries, and these. I know you're not sure, Alexa. I know, and it'll transmit data to those queries. So it'll get the queries to be run on those compute nodes. So you can have 2 different EC2 instances for Redshift. So you can have compute optimized. So if you want to have a lot of input output, you're going to use that. Or if you want to store a lot of things, you'll use DS for dense storage. So for Glue, what is Glue? It's a fully managed ETL service. So if you want to transfer the data or load it somewhere, you can use Glue for that. It'll all be done for you, and you don't have to do any Lambda fancy work. Oops. So some services that can do some data analysis for you are Athena, Hadoop framework using EMR, and QuickSight. QuickSight will also give you visuals, which is very useful. Kinesis Client Library. What is this? So it can build an app with KCL that can pre-process the streaming data as it arrives and emit the data for generating incremental views and downstream analysis. So what does that mean? It can analyze data for you, so you don't have to do it yourself, basically. So DataFirehose makes it really easy to batch and compress your data and generate incremental views. So it also allows you to execute custom transformation logic, so you can transform your data using AWS Lambda before delivering that incremental view to S3. So data analytics. It enables the ability to gain actionable insight in near real time from incremental stream before storing it in S3. So onto the KPL, the Kinesis Producer library. So it buffers records before they're sent to a Kinesis stream. So this is how you get the data onto Kinesis. If your app does not log records to a local file and it creates a large number of small records per second, you're going to use this Kinesis Producer library. So onto API. So operations that can be added to a stream, you can either use put records or put records. This is kind of self-explanatory. Put record for one thing, put records for multiple things, and put records will speed things up if you're using multiple records. So use if you're unable to use KPL or Kinesis agent. So that's when you're going to use the API, basically. So the processing data in Kinesis streams, there's Kinesis Analytics. You can use KCL, Lambda, or Kinesis Streams API to process your data. So API, there's get records and get shard iteration. So these are just some API commands you can use for Kinesis. Oh, sorry, get shard iterator to find out which shard iterator is, what shard you're on right now. So Firehose, it can concatenate multiple records and deliver them to S3 as a single S3 object. So it's very useful. If for a very simple streaming use, you're going to use Firehose. So DisCP, what is it? It'll be used to transfer data from an on-premise Hadoop cluster to an S3 bucket. And then the Hive Metastore catalog, or the H catalog, will contain info about all assets that have been transformed into formats and table definitions that are usable by analytics tools. The comprehensive data catalog can be used to search for all assets in the data lake. So the H catalog can be used to discover and query these data assets in the data lake. The data assets must be loaded into Amazon Redshift before they can be queried and run. Before the queries can run. So Redshift Spectrum is pretty cool. It enables you to run Redshift SQL queries directly against massive amounts of data. So you don't need to load the data into Redshift. You can run it directly. So recognition is an interesting service. So it allows you to have image recognition powered by deep learning, which will be run against image data assets in S3. So you can load an image to S3 and you can use image recognition on those images. So Pig is for EMR. It's an open source analytics package that runs on Hadoop. So you can use it for processing of complete and unstructured data sources, such as text documents and log files. So Presto is another thing for EMR, or another package for EMR that when you start up EMR you can use. So it's for distributed query engine. So this is what it is. The query engine optimized for low latency ad hoc analysis of data. So the Kinesis connector allows you to connect EMR basically to Kinesis. So it allows EMR to directly read and query data from Kinesis data streams. S3 DistCP is an extension of DistCP that uses MapReduce to efficiently move large amounts of data. So some of the anti-patterns for EMR are small data sets and ACID transactions. So what is ACID? ACID is atomic, consistent, isolated, and durable. That's what it stands for. So Glue uses a scale-out Apache Spark environment to load data into its destination. It requires data processing units, a Glue ETL job, and requires a minimum of 2 DPUs, or data processing units. So if you want to run Glue, you're going to need 2 of those data processing DPUs. And some of the anti-patterns for Glue are going to be streaming data. If you want to use streaming, use Kinesis, or multiple ETL engines, or NoSQL databases. All right, on to the Elasticsearch service. So Elasticsearch makes it easy to deploy, operate, and scale Elasticsearch for log analysis, full text search, and app monitoring. So it integrates with Kibana. What is Kibana? Kibana is an open source data visualization and exploration tool used for log and time series analytics, app monitoring, and operational intelligence. So it has a bunch of different use cases, and one of those is interactive charts. Or it has interactive charts. There's also Logstash, which integrates with the Elasticsearch service. So Logstash is a lightweight, open source server-side data processing pipeline that allows you to collect data from a variety of sources, transform it on the fly, and send it to your desired destination. So you can get a bunch of data and send it to wherever you want to send it. Seems pretty useful. QuickSight, we had this before. So it now enables orgs to scale their business analytics capabilities to hundreds of thousands of users. So you can make a bunch of visualizations for all those different users. So it's built with Spice. What is Spice? Spice is the super fast parallel in-memory calculation engine. It sounds really cool, but the super fast makes it sound really cool anyways. Athena is very important. You can be using that to query S3 directly with SQL. So it can be integrated with RStudio, Jupyter, or Zeppelin, and it can save by converting data to columnar formats. All right, so now we're going to go into a flowchart AWS had on their documents that had them decide if you want to use which disk style you want to use. So this is for Redshift tables. And this will optimize which table. So let's go through this. So do you have joins? Let's go through the negative path first. So no, you don't have any joins. Do you have at least one potential disk key column? No, you're going to go to disk style even. If you do have a disk key column, you're going to go to a disk style key. Sorry. So let's say you do have joins. What about if you have additional storage overhead toleration? So you can tolerate more storage. Or can you tolerate more storage? If you know, then you're going to go up to this path again, and you'll decide if to style key or even again. But let's say you do have toleration for that. Then do you have toleration for reduced parallelism? So if you do have toleration for this, then you're going to continue on. If else, you're going to go back to the style key or even again. And then if you do have toleration for this, you're going to go to one disk, see if you're going to have one disk key column. If you do, then you can query patterns with the disk key columns and join. If you have that, then you have disk style key. If not, then you want to go to disk key all as your distribution style. But in other words, if you have key in all in cases, you want to use key in all in cases where at least one valid disk key column exists, and even in all in cases where no valid disk key column exists. So now we're going to move on to the decision making behind which sort key you're going to use. So this is for Redshift tables again. Will sorting enable more merge joins? If yes, then use the compound sort key. If no, then you're going to have to ask, will sorting reduce sort steps? Then if yes, back to compound sort key. If no, we'll have to ask, will sorting improve zone maps? If yes, then it could also be a compound sort key, or it could also be interleave sort key. This is where there's a little bit of confusion. It could be both of interleave and compound here if it can improve zone maps. And else, then no sort key, because the sort key could potentially slow things down. It doesn't take up much computation having a sort key, but it's better to not have one. So interleave sort keys help with large tables. That's one of the differences between compound sort keys and interleave sort keys. So now onto the question of if you want to compress or not compress one of your columns for Redshift. So compress or not to compress? That is the question. So let's go on to a column. So will compression result in savings of storage now or in the future? If no, then you don't compress. If yes, then you have to ask, does compression result in a large row offset? If no, you want to compress the data. If yes, you'll have to ask, is resolving this degradation prioritized over reducing storage footprint? If no, you want to compress. And yes, don't compress. So this is my little study session for big data. This is by no means everything. There's a lot more to big data. This is just some of the topics that I found were not memorable at the time. But thank you for watching. I hope you learned something, or maybe not. Don't light your house on fire. But all right, thanks for watching.